Okay, math is frequently very much about very exact language. And I want to make sure that we all know exactly what we mean when we say these three very important loaded words. You've probably noticed, as you've done lots of math, that the majority of algebra questions ask you in some way, shape, or form to do one of those three things. Okay? And you probably have a pretty good idea what they all mean, but let's just take a second and make sure. For just a moment here, let's get in groups of at least 2 per table. So shuffle around if necessary. At least 2 per table. I don't care if it's 2 to 4. Hey, that's fine. Take a second and at your tables and take this seriously. Take a second and just hash through what you know about those three things. What we want to work towards is sort of a mathematical definition of each of those three verbs. Okay? Take, just a minute or less, just real quick. Solve. Hear that one a lot. What's it mean to solve something in math?
Find a solution.
Find a solution. Okay, but what's a solution? An answer. Okay, but an answer, I need something a little more than that. It's kind of difficult, isn't it? It involves an equal sign much of the time. What else might it involve other than an equal sign? A solution. A variable, always, typically, always a variable, isn't it? And that's a key part of this. Okay, in math and algebra, when we are solving equations or maybe what else? Inequalities. Could be solving inequalities too. We're always going to express our answer in terms of a variable. That's true. Now let's take I think it's easier to see perhaps if we're focusing on a concrete example. So let's do that. Here's just a real simple example of an equation that you might solve. Now, you all pretty much know what to do. I'm sure you do. If we're supposed to solve for x, everybody take a second. Don't say anything out loud for just a second. Do this in your head. You guys can all do this in your head. Find the solution. What's the solution? Just as a group, what is it? 4. Yeah. The solution more precisely. Okay, should I have everybody's attention up here, please? The solution more precisely would be x equals 4, right? Make sense? Okay, why? Why is that the solution? Okay, say it again. Yes, okay. Okay, because we isolated x, maybe. Okay, the way that we solve this algebraically is we are going to go through the algebra steps required to isolate x. Good. And thank you. That's much of what algebra teaches you to do, is how to recognize and execute those steps properly so you can isolate a variable, you can solve for a variable, right? Now, once we've done that, once we've gone through the algebra to isolate x and get the answer x equals 4, I still want to know, what does that mean? Why is that significant? Why is that the solution? Prove to me that's the solution. Well, I'll plug it in. If I plug it in, what happens? If I plug it in, I get 3 times 4 is 12 minus 1 is 11 equals 11.
So yeah.
That's true, isn't it?
Yes.
Okay, so when we solve something in algebra, we find a solution. The solution is the value in this case. In some cases, maybe there are multiple values of the variable that make the original equation or inequality true. Now, we've got a way of saying that in math. That's kind of wordy. In math, we like to make things very concise. So in math, in algebra, we'd say we're going to find the value or values of the variable that satisfy the original equation or inequality, right? So in this case, x equals 4 is the value of x that satisfies the equation, makes it true. The equation is satisfied when it's true, it's dissatisfied when it's false, right? Make sense? Okay. While we're on the subject here, let's take a quick look what happens here? What if I have solve that one? Okay, if I try to do this problem, what do I get? Okay, if I want to get the x's, I can subtract x from both sides, right? And I get the answer 2 equals -3 when I do my algebra steps. Is that true or false?
False.
That's false, right? And so no matter what I do here, what this tells us is no matter what value of x I choose, I'm never going to get an answer that's true. It's always going to be false. And so we've got a little bit of a dead end here. Can we solve this one? No, there is no solution. There is no way to make a true statement out of this. There's no value of x we could ever choose that would make that equation true, right? Now, what if it was something like, instead, let's tweak it a little bit. What if it had started off being x plus 2 equals 2x, actually, we're just going to make this easy. It's just going to be x plus 2. We'll just make it simple. This time, if I subtract x from both sides, I get the solution 2 equals 2. What's that tell us? It's always true, isn't it? Okay, this is one where there are many, in fact, an infinite number of solutions, right? No matter what value we pick for x plus 2 equals x plus 2, always, right? So those are kind of some weird cases, but usually we're more interested in cases like this, where there's maybe a single solution or just a finite set of solutions, okay? All right, so we got the solve thing down, maybe, right? Let's talk about simplify. Now that's different. What does it mean when we're asked to simplify something?
Combine like terms.
Okay, maybe combine like terms, make it smaller. If something is simplified, is it smaller or bigger? Small. It's like that commercial with kids, right? It's smaller. Yeah. It's easier to express. It's less complicated, right? So here's maybe an example of a problem where we might be asked to simplify something. What are we going to do there? Combine like terms in this case, right? If I add up the like terms, and when you throw out the word term, what is a term, by the way, in math? How many terms are there in that? Now this is an equation, right? Up above? Agreed? How do you know it's an equation? It has an equal sign. Okay, good. So it's risen to the status of equation. Now this guy right here in the second example, is that an equation? No, it doesn't have an equal sign. It hasn't been promoted to equation status yet. What is it instead?
Expression.
It's an expression, yeah. An expression is just some combination of variables and constants and coefficients. And are these words all ringing a bell? Right? Coefficients are numbers multiplied by variables. Constants are just numbers by themselves, right? Operations, pluses and minuses, things like that. Okay, what's a term? So we got this expression. How many terms are there in that expression? 4. Good. So what is a term? We had to define that. Expressions are algebraic things that are what? Maybe. What's being done to those things that make them expressions? Let's contrast that maybe. Now, what if I say, what if I say 2 times, we'll just make it x. Now in this case, 2 and x are being multiplied. And so, what would we call those two things? Anybody know? What are things that are being multiplied?
Products?
It's a product of factors, right? 2 and x are factors because they're being multiplied together. And we'll get onto that in more detail later. But these are terms. Factors are things that are being multiplied or maybe divided. But what are terms? Things that are being added or subtracted. Yeah, that's it. Nothing more complicated than that. terms in algebra are just algebraic entities, algebraic things that are being added together or subtracted, right? Okay. Oh, they won't do that. Just wanted to do maybe that. Okay, so we could just add these up by simplifying or simplify this by adding up like terms. So what, I get 5x minus 6, no big deal. You know what to do. But that word, I want you to just know what that word means. Evaluate. What does it mean to evaluate, you suppose?
Solve.
It's different than solve. Solve is something different. Evaluate is probably easier to do. The hardest thing up there is probably solve out of those three, typically. Evaluate's different. Now, evaluate's a verb. Is there an important noun that's embedded in that verb? Well, in this, if I look at the verb evaluate, is there an important noun in here? Value. Yeah, value is important. What does value mean in math?
Quantity?
Yeah, quantity. It's expressed as a number, right? A value is a number. If I hold up two bills and one's a $10 bill and one's a $100 bill, which one do you probably want? The $100 bill, right? Well, why? They look the same. What's the difference? The value. The value of the $100 bill is much greater than the value of the $10 bill because the number is different. The number's bigger, right? So the same kind of thing is true. I mean, that's essentially a number issue. The value of a number, or a value is just a number, right? So if we want to evaluate something like, let's say this, evaluate this function, f of x, when x is equal to 2, what are we going to do? Plug 2 in, yeah. We're going to plug in the number 2 to find the value of the function when x is equal to 2, when x has a value of 2, right? So it would just look like, if we want to do that math, isn't it really the same thing as saying find f of 2, right? Every place I used to have an x, I'm just going to plug in a 2. So what's my answer? 8. Good. Okay, 2 squared is 4 times 2 is 8, right? Makes sense? Okay. Now you did some stuff like that on the assignment. Solve some equations and some inequalities. Just to kind of warm up here a little bit, everybody try this one on your own. Now get out a piece of paper or your notebook or something. What if I have something like, what's the next bit? Try that. Take a second and work on it completely independently, and then you can check yourself if your neighbors. Check it, compare answers and see what you get. So if we're going to solve this inequality, we're trying to find all the values of x that satisfy the inequality to make it true. You get the same thing as your neighbor? One really key part here that if you're going to miss anything, there's one little trick here. What are the steps we go through? Say it again. Okay, good. To isolate x, we're going to subtract 1 from both parts. So we get negative 2x is less than or equal to negative 12. Now what's the last step to get the x by itself? Divide by negative 2. And then we get an x over here, and negative 12 over negative 2 is? Okay, now what goes in the middle? Okay, yeah. Now, when there's one difference, isn't there? when we're dealing with the algebra of inequalities compared to the algebra of equations, all the rules are pretty much the same, except when we multiply or divide both sides by a negative with inequalities, what do we have to do? Yeah, good, we have to flip the sign around, don't we? So this becomes a greater than or equal to. Okay? So what do you do with something like this then? What if I have, say, 2x plus 3 is greater than 7 and less than or equal to 15? What do we call that animal? Is that an inequality? What kind of? How many of them are there? 2 of them. Okay, this is what we call a compound inequality. This is an and inequality or a conjunctive inequality. Okay, and you know that by the way that you read this guy. Now there's a tendency, and this is really important in math, to make sure we're able to communicate this stuff accurately. There's a tendency to want to read left to right, like we do with text, and say 7 is less than 2x plus 3, and now we have problems, don't we? Which is less than or equal to 15. That's a little bit jumbled up. What we want to do is we want to always start with the variable in this case. So we're going to start with this stuff in the middle, and we're going to say, okay, the expression 2x plus 3. So 2x plus 3 has to be pinched between the lower limit of 7 and the upper limit of 15, right? And so we always start in the middle and we'd say 2x plus 3 is greater than 7 and less than or equal to 15. And so we got to make sure we get that and in there because this is specifically an and compound inequality, right? Now, how do we solve an and compound inequality?
Can we take away 3 from all 3 sides?
We can't. We can't. We can do all this stuff at once here. We're going to treat each of these 3 cases, the left, the middle, and the right, equally. We have to just apply our algebraic rules, but apply it to all 3 places at once. Okay? So I'm going to subtract 3 from everything. And what's that give us? Well, over here we're going to get, in here we're going to get just our 2x. That's good. We're trying to get the x by itself, right? And then over here we're just going to get a 12. Do we need to flip the inequalities? No need. Okay, now what? Divide by 2. So that's going to give us what over here? X and, oops, 6, you're right. Do I need to flip the inequalities? Do not. Because I divided by a positive, right? So they don't change. All right, so now what's that going to look like if we graph it on the real line, the x-axis? So let's say that's 0, 1, 2, 3, 4, 5, 6, 7. What's that going to look like?
Like 2.0000 and then 1 or something.
Okay, so we could just, now, we could just take a bunch of points and graph a bunch of points and connect them. Now, except, how many points are going to be included in that set? An infinite number, so that might take a while. So rather than just graph individual points, maybe what we want to do here is establish what are going to be the endpoints of the interval, and just fill in everything in between, right? Yes, sir?
Wouldn't it be, you do an open dot on 2 and
Okay.
a closed dot on 6?
Okay, good. So we know that x has to be greater than 2, so one of our endpoints is going to be at 2, right? X has to be less than or equal to 6, so we're going to put an endpoint over here, and then everything in between would be okay, wouldn't it? Right? All those values fit our criteria. Now, it is important that we get the endpoints correct here. If x is greater than 2, x has to be greater than 2, could x be 2? No, it couldn't, but it could be something like 2.00001 would be fine. In fact, we could get as many zeros as possible, infinite number, and then a 1. That'd be okay. It has to be some number bigger than 2. But in order to indicate that we're not including the 2, remember, we got to put that open dot there, right? Is 6 okay? Could x equal 6? Yes, it could, because x is less than or equal to 6, and therefore we fill in that dot, right? Make sense? Okay, now that's an and statement, isn't it? If an ant is walking along the x-axis, and that ant is going to be restricted only to the red part, well, then that ant has to be to the right of negative of 2 and the left of 6 at the same time. That's an and statement, isn't it? Right? He's connected to both of those endpoints. He has to be the right of this one and the left of that one, right? Okay, so, good. What about this? Try one more of these, and then I think we're ready to go. How about if we have 2x plus 1 is negative 2x plus 1 is less than or equal to 5, or negative 2x plus 1 is greater than, we'll just do greater than, 11. Okay, that's also a compound inequality. But this is an OR inequality, so technically we call this a disjunctive. Because it uses the word OR. Okay? Now these kind are a little different. These kind, we just have to do both of them separately. And our answer is going to include both parts. So we got to solve the left part of that compound inequality first over here. What are the steps we'd go through to solve for x here? Okay, we subtract 1. So negative 2x is less than or equal to 4. Right? Now what? Divide by negative 2. So that's going to give me an x over here and a negative 2 right there. Now what do I have to do in this case? Got to flip them around, don't I? Okay, so we're going to get that. Okay. Or, what about over here? Okay, I'm going to subtract 1. So I'm going to get my negative 2x greater than 10. Divide by negative 2, so I'm going to get an x and a negative 5, and got to flip it. So that's my answer. Right? And if I were to graph this one, we'll make this quick. Let's see, where are my endpoints going to be this time? If x has to be greater than or equal to negative 2 or less than negative 5, where are the important points? Negative 2 and 5, right? So here's negative, whoops, that's negative 5. And then to the right of that someplace is negative 2, right? Maybe we could fill in the blanks if we wanted to. Which parts get shaded? How do I say this stuff over here? X is greater than or equal to negative 2. What do you think? Second one, right?
Circle the negative 2 and put it all to the right.
Solid or solid, okay. So a solid endpoint, we're going to go that way, right? What about this one? X is less than negative 5.
Open circle and to the left.
Okay, open endpoint to the left. Good. Make sense? You good? Okay. Now notice that the solution this time, if an ant can only walk in the red parts, that requires the use of the word or, doesn't it? Either the ant is walking over here to the left of this endpoint, or he's going to be walking over here. He can't be in both places at the same time this time, right? Make sense? And an easy way to remember that, I know this is kind of basic review, OR is on a boat. If you graph an OR inequality, compound inequality, it looks like the OR is on the boat sticking out to the side. Okay? Make sense? Are we done? Okay, yeah, I think we're done. Let's head down. I'll let you finish up that first assignment. I'll post the second one here as quickly as I can.